This lecture introduces the Cournot problem, which you may have seen before. We'll keep it really simple, and we will choose to optimize a revenue problem rather than a profits problem. You discover a natural spring on your property. It also flows through your neighbor's property. The demand for natural spring water is given by the formula Q equals 100 minus P, where P is the price in cents per bottle, Q is the number of bottles demanded per day. What is the maximum amount of money that you can earn per day? We will sketch the demand analysis with price on the vertical axis and with demand given by P equals 100 minus Q, the inverse demand. We will sketch that inverse demand curve starting at P equals 100 on the vertical axis. MR equals 0 then is where we maximize revenue, which is the midpoint of the demand curve. Price equals 50 and quantity equals 50. Revenue is equal to 2,500 at that point when there is only one firm present. Remember, the problem asked us, how does the answer change if our neighbor decides to enter the market? So we assume that firm 1 is the only firm present in period 1, and it maximizes revenue at R equals 2,500, which is at the midpoint of the linear demand curve. In period 2, firm 2 sees firm 1's profits and decides to enter the market because it has the right to. It will then view the unmet demand as its market segment. So with the first 50 customers satisfied, firm 2 looks at the second set of customers and asks, how can I maximize my revenue, given that there are 50 customers whose demand is yet unmet? Firm 2 sees an opportunity to view the unmet demand as its potential market. And for this market segment, Q equals 50 minus P, P equals 50 minus Q. We determine Q2 as 100 minus P minus Q1, which is 50 minus P. And the midpoint of that line segment is at Q equals 25, Q2 equals 25 at a price of 25. 25 times 25 yields a revenue of 625. Notice that in the process, because firm 2's quantity adds to firm 1's quantity, the total quantity being supplied is 75, and according to the original demand curve, Q equals 100 minus P, a quantity of 75 generates a price of 25, so both firms will get a price of 25, which means that firm 1's revenue will be cut in half because the price is cut in half for the 50 units it is supplying. Firm 1's revenue falls to $12.50, and firm 2's revenue is $6.25. This is period 2. Let us move to period 3. Firm 1 will retaliate to firm 2's entry and will decide that if firm 2 is going to supply 25, it will determine that the unmet demand after the first 25 customers are satisfied will be 75 minus P. Q1 equals 75 minus P, and the marginal revenue here would be 75 minus 2Q, MR equals 75 minus 2Q. This will yield a price of 37.5 and a quantity for Q1 of 37.5. And firm 1's revenue is now 1406.25. In the process, firm 2 is going to see a 50% increase in the price from 25 to 37.5, so firm 2 also wins when firm 1 retaliates. If we take a look at our analysis in period 3, we notice then that R1 is 1406.25 and R2 is 937.5, which is 50% higher than the 625 firm 2 made in period 2. The joint revenues in the industry will increase as the quantity decreases overall. So this decline in quantity will boost prices, and we can continue to do this analysis. Period number 4, we expect firm 2 will retaliate to firm 1's action, and it will actually, in the process, make more revenue because the point of retaliating is so that you can increase your revenue. Remember, this model is a naive model, and you behave based on the last reaction that your competitor engaged in, and therefore the model keeps going on and on an infinite number of cycles, and it settles down at the price of 33.3 for both firms and the quantity of 33.3 for both firms. So the revenue for each firm will be 1111.1 at the end of this game, which is at infinite number of repetitions, which means it really does not settle down. It keeps changing until it asymptotically approaches this outcome. The main point here is that both of them will end up with 1111.1, and firm 1 is obviously earning less than started with. We ask, what is a better solution for firm 1? We will see that if firm 1 had opted not to retaliate, its revenue would have fallen from $2,500 to $1,250, and if firm 1 had accepted that the ultimate outcome will be 1111.1, it should not have retaliated to firm 2's entry. The 1111.1 outcome after an infinite number of cycles is called the Cournot equilibrium, but the idea of not retaliating to firm 2's entry and obtaining a higher revenue is called the Stackelberg outcome. So the best response to entry by firm 2 when you cannot keep him out is to accept his presence in the market. We can use a sophisticated analysis to solve this problem, or we can use a very simple idea. I think I want to keep it simple so that you get the idea. Two ideas. One is that this game goes on for an infinite number of periods because of the naivete of the two players, and also if one of them would be wise enough to see where the end result of that infinite number of cycles will be, that firm should just short circuit the game and not retaliate to entry by the second firm.